Since someone asked for this is a very quick and simple video demonstrating some of the mods I'm working on for the Monotribe. To be honest, I'd already started breaking apart the breadboards that I used to test the circuits, and so I can't really, without a bunch of extra work, I can't really demonstrate all of the features, but I should be able to show a few of them anyway. Again, I'm not using an external mic or anything, so this is very quick and simple, and hopefully you'll be able to hear. I'm not going to do any special kind of music or really test the limits of the feature. I'm just going to kind of demonstrate them very simply. The first thing I'm going to show, so I've got the VCO2 hooked up here. The first thing I'm going to just demonstrate is using that to control the VCA as opposed to the envelope generator. On the oscilloscope I've got, the yellow trace is going to be the input to the VCA, and the blue trace is going to show you my gate signal out, which you could use to control another synthesizer or whatever. But anyway, that'll just give you an idea of some of what's going on. Right now, of course, the sequencer isn't running on the Monotribe, so you don't hear any sound coming out. But if you use VCO2 to control the VCA, there will be sound coming out regardless of whether the sequencer is running or not. So for example, we've got the switch here now for envelope generator or VCO2, so we're going to switch that to VCO2. Now you get the triangle signal at a VCO2 is set for low frequency, so it's at about 0.5 hertz. 500 and so millihertz. You can hear the ascending and decreasing VCA volume. That's my gate signal. You can see that it's low only when the triangle is at the lowest point of its. You can change the gate threshold here if you want. So you can increase it so that it's low for up to a certain point of the input to the VCA. So clearly that's the VCA being operated without the sequencer running. If I now turn the sequencer on, the sequencer will deliver the notes and the CV voltage as normal, but the VCA is still going to be controlled by the triangle wave. Now if we increase the frequency of the VCO2, you're going to of course change the So now we're at about 3 hertz, and let's even go faster. That was the fine adjust. I'll turn up the coarse adjust. So now you basically have LFO modulation of the VCA. And if I would switch back to just the normal EG of the controlling the VCA, you'd hear this. Again, you can see the signal there. Envelope generator, LFO2. Okay, next we're going to look at VCO1 plus VCO2 being input to the VCF. As you can see on the oscilloscope, I've got VCO1 triangle wave going there, and there's the sequencer is running even though the gate, the VCA isn't being turned on and off. So there's frequencies which are fluctuating here on VCO1, and actually they're on VCO2 as well. I just have the volume turned down at the moment. But so I'm going to start this going, and then I'm going to increase the volume so you can hear VCO2, the VCO2 triangle wave being added to VCO1. And then I'll switch this toggle switch, which will change the output of VCO2 to square wave. So you'll hear that added together with this. And then we'll just look at the control voltage tracking briefly. So let's start this going. Now we'll just add in VCO2. There's VCO2 up there. Now we're going to switch to square wave. We're just going to pause that for a second. We're going to just look at the lower here. It's about 4+ octaves of tracking. Oops. Oops. Sorry, everything's, the breadboard's a... You have to imagine the tracking's a little bit flaky because look at the breadboard. I mean, it's drifting slightly, but anyway, you get the idea. Slightly detune it more. Okay, now I'm going to demonstrate the sync between the two VCOs. I've got VCO2 above, VCO1 below, and right now they're completely out of tune. And if I increase the sync so that it starts to soft sync, you get now we've got a soft sync happening. I'm going to go hard sync. Now we're hard synced. It's actually resetting the VCO2.